Welcome to Brought to You by AI, the channel where we dive deep into emerging technologies and simplify complex concepts for everyone. Today, we're focusing on self-driving cars, also known as autonomous vehicles. You've likely heard the buzz. Tech giants and automotive companies are racing to perfect driverless technology, promising a future where you can simply sit back and let the car do the work. But how do these vehicles actually function? Are they truly safe? And what will happen to our roads and lifestyles once self-driving cars become mainstream? Stay tuned as we take a comprehensive look at the sensors, AI algorithms, and key challenges behind autonomous driving. Defining self-driving cars. First, let's clarify what we mean by self-driving or autonomous cars. These are vehicles equipped with systems that can perceive their environment and navigate from point A to point B with minimal, or even zero, human intervention. While traditional cars rely entirely on the driver's reflexes, eyesight, and decision-making, autonomous vehicles leverage a sophisticated combination of hardware and software. The Society of Automotive Engineers, SAE, defines 6 levels of driving automation, ranging from Level 0, no automation, to Level 5, full automation, no human driver needed. Right now, most commercial solutions we see on the road are somewhere between Level 2 and Level 3. Where the car can handle certain tasks but still expects a human to take over when necessary. The technology stack, sensors, data, and AI. At the heart of every self-driving car is a network of sensors. Cameras capture high-resolution images of the surroundings, allowing the onboard computer to recognize traffic lights, road signs, and lane markings. Radar sensors measure distances and relative speeds, critical for detecting how close other vehicles are or if there's a suddenly slowing car ahead. LiDAR, which stands for light detection and ranging, emits lasers to create a precise 3D map of the environment. This helps the system identify objects' shapes and positions with remarkable accuracy. Ultrasonic sensors typically handle short-range detection, useful for tasks like parking or avoiding curbs. But sensors alone aren't enough. The real magic lies in how the data is processed. Advanced machine learning models, often powered by neural networks, integrate streams of sensor data to develop a cohesive scene of the vehicle's surroundings. These neural networks have been trained on massive datasets, sometimes involving millions of miles of driving footage and countless simulations. Over time, they learn to interpret road conditions, predict other drivers' actions, and select the safest possible maneuver, be it changing lanes, braking, or accelerating through a green light. This fusion of sensors and AI forms the backbone of self-driving technology. Current leaders and real-world testing. Tesla, Waymo, owned by Alphabet, the company that also owns Google, General Motors Cruise, and a host of other companies are at the forefront of this movement. Tesla's autopilot and full self-driving (FSD) systems use a camera-centric approach combined with powerful neural networks trained on vast amounts of real-world data. Waymo, on the other hand, relies heavily on LiDAR and has already launched limited robotaxi services in certain US cities. Cruise is similarly testing driverless taxis in urban environments. These companies continuously gather data from test vehicles on public roads, refining their algorithms to handle everything from construction zones and unpredictable pedestrians to bad weather and nighttime driving conditions. Safety, regulations, and ethical considerations. Despite the rapid progress, safety remains the biggest question. Autonomous systems need to reliably handle edge cases, rare but critical scenarios like sudden tire blowouts or a child running into the street. Regulations also vary by region, with governments slowly adapting laws to define liability and operational constraints for self-driving cars. Ethical dilemmas add another layer of complexity. How should an AI prioritize actions in a potential accident scenario? Balancing safety, legal responsibility, and public acceptance is a huge challenge that every developer in this field must face. Still, many experts argue that once perfected, self-driving cars could dramatically reduce the over 90% of traffic accidents caused by human error, potentially saving thousands of lives each year. The future impact. Looking ahead, the proliferation of self-driving cars could reshape entire cities. Ride-sharing services might dominate, leading to fewer privately owned vehicles and a significant drop in parking lot requirements. Highway congestion could decrease as AI-driven vehicles coordinate speeds and routes more efficiently than humans. Industries like trucking and delivery could transition to automated fleets, changing the job market and supply chain dynamics. Ultimately, the biggest promise of autonomous vehicles is to offer safer, more convenient travel options for everyone, from daily commuters to those who currently can't drive due to age or disability. Conclusion. So, will self-driving cars transform the way we travel in the coming decade, or are we still a long way off from seeing fully driverless roads? Let us know your thoughts in the comments. Do you welcome the idea of handing over control to an AI, or does it make you uneasy? If you enjoyed this in-depth look at autonomous vehicles, remember to subscribe for more, brought to you by AI, videos on emerging technology. Thanks for watching, and stay curious.